Hello everyone and welcome to week 6 of remote learning. Today we are beginning our final unit of the year. We have 2 short 4-day weeks left and we will be covering transformations within that time. Today we are beginning with reflections. A reflection is a transformation that flips a figure across the line. So if you see in this picture down below, the left image shows a reflection where the figure is flipped over the line and shows a mirror image of the original image. If it is not a reflection, it looks like this second image where you'll notice that the short side of the shape is now on the opposite end and across the line. That is not a reflection. So all points should be moving in the same direction, and if you look at the not a reflection, this point comes down here and this point comes down here. So they're not moving in exactly the same direction. Other things you need to know. The line of a reflection is the perpendicular bisector of each segment joining each point and its image. So we have this line that we are reflecting over, and that line is a perpendicular bisector between the original A and our new point A, the original point B and the new point B, and the original point C and the new point C. The line of reflection can be horizontal, vertical, diagonal, or in any other direction, and the reflected image is always the same size, just facing the other direction. When we reflect on the coordinate plane, certain changes take place in the coordinates of our preimage that depend on the type of reflection. 3 specific types of reflections in the coordinate plane are explained below. We have across the x-axis, across the y-axis, and across the line y equals x. Let's start with reflecting over the x-axis. If you look at the coordinate points, we have x, y turns into x, negative y. So essentially what you're doing here is you're saying we're going to keep x and then we're going to negate y. So we're going to take the opposite of whatever y is. And that moves our point over the x-axis. It crosses over the x-axis. If we're reflecting across the y-axis, it's the same thing where you start on one side and you move over the y-axis to the other. When we look at the coordinate points, we have x, y becomes negative x, comma, y. So what you're doing in this situation is you are negating the x and you're keeping the y. Last but not least, we have across the line y equals x. So this is a angled line that we're reflecting over, and we're crossing over this reflection line, the line of reflection. If we look at the coordinate points, we have xy becomes yx. So what's happening here is you are flipping x and y. Those are the 3 different types of reflections and how you solve for them. So now let's go ahead and look at a few examples. Example number 1 says, draw the images after the figure below has been reflected over the x-axis. Label the points on both the image and the preimage. Okay, so the first thing I want to do is identify what my points are. I have A at negative 2, 2, and I have B at 3, 3, and I have C at 2, 1. And while I'm at it, I'm just going to go ahead and label the points for the second image as well. So I have P at 2, 3, Q at 4, 0, R at 1, negative 4, and S is at 0, negative 2. All right. So let's start with that first image. We have a triangle ABC, and I want to change my coordinate points so that I can draw my new image. So I'm going to start on the side over here. I have A at negative 2, 2, and A is flipping over the x-axis, so we're making the change from A to the new A. Because we're going over the x-axis, that means that what we're doing is we are keeping x and we're taking a negative y. So we have for our A, keeping x, still negative 2. Our new y, we have to negate. So I had a positive 2. So now because I'm taking the negative of that, I have a negative 2. And now I want to do that same thing for the other 2 points here as well before I graph it. So I have B at 3, 3, and C at 2, 1. And I'm negating the y's on those and keeping the x's to get my new points. So I have B, my new B is at 3, negative y is negative 3. My new C is at 2, negative 1. Now I want to go ahead and plot those points. So I have negative 2, negative 2 gives me my new A. I have 3, negative 3 gives me my new B. And I have 2, negative 1 to give me my new C. When I connect those points, I should see a mirror image of the shape I previously had, although not if I delete it, so we'll fix that there a second. There we go. If my lines were straight, it would be an exact copy of the original image. You're just going to have to bear with me on these lines. They're not going to be perfectly straight. All right, let's go ahead and look at this second image here. Same process. We're going to go ahead and list out all of those points on the side here. So I have my P at 2, 3, Q at 4, 0, R at 1, negative 4, and S at 0, negative 2. We're reflecting over the x-axis, so we keep the x. For my new P, we have 2, and we negate the y, so I now have a negative 3. My new Q is at 4, 0. When you put the negative in front of it, is still 0, so that one is actually going to be at the exact same spot. My new R, we keep the x, negate the y. It was negative 4, so now it's a positive 4. My new S, 0 stays the same. Negative 2 becomes a positive 2. Now let's go ahead and plot those points. So I have 2, negative 3 gives me my new P. 4, 0, Q is at the exact same point. That's my new Q. My new R is at 1, positive 4. And my new S is at 0, positive 2. Now I want to go ahead and connect those points. And that is my image after it has been reflected over the x-axis. So again, you want to make sure that your line from the original point to the new point, the straight line, crosses over the x-axis. If it's crossing over the x-axis, you're in good shape, you're moving in the right direction. Example 2 says draw the figure A 4, 4, B 3, negative 1, C 1, negative 2 in the coordinate plane below. Then reflect the figure over the y-axis. Label the coordinates of all your points on the plane. So we're going to go ahead and start by plotting those points. So I have A at 4, 4, B at 3, negative 1, C at 1, negative 2. Now I'm going to go ahead and connect those points, A to B, B to C, C to A, connecting in the order they were written. And now I want to go ahead and find my new points. If I'm flipping over the y-axis, let's go ahead and write down those coordinate points to the side here so that we have some space to show our work. So I have B at 3, negative 1, C at 1, negative 2. In this situation, it says that we are flipping over the y-axis, so that means that we are having a negative x and we are keeping the same y. So my a becomes my new a, where I negate x. So I previously had a 4, so now I have a negative 4. And then I keep my y. Previously I had a 4, so I keep that 4. My new b, we negate the x, so I now have negative 3, and I keep my y, so it's still negative 1. My new c, I negate the x, so I have negative 1, and I keep my y, so that stays at negative 2. Now I have my new points, and now I want to go ahead and get those plotted on the graph. So I'm at the point negative 4, 4. That's my new a. Negative 3, negative 1. That's my new b. Negative 1, negative 2 is my new c. If I connect those points, I should have a perfect mirror image of the original shape, and that looks good. And again, if you want to just check to make sure you are going in the right direction, if you start on one point and move in a straight line to the new point, you should be going across the y-axis. If you're not going across the y-axis, then there's some issue in your reflection. Number 3, draw the figure JKLM in the coordinate plane below. Then reflect the figure over the line y equals x. Label the coordinates of your points on the plane. Alright, let's go ahead and start by plotting our points again. So I have J at 3, negative 4. So that's going to be my J. I have K at 1, negative 1. That's my K. I have L at negative 1, negative 1. That's my L. I have M at negative 2, negative 4. So that's my M. I'm going to connect those dots following in the order that they were plotted. Alright, and now to show my work, I'm going to write these points out to the side here. J at 3, negative 4. K at 1, negative 1. L at negative 1, negative 1. And M at negative 2, negative 4. Alright. It says that we are on the point, or that we're reflecting over the line y equals x. That means that we are flipping or swapping x and y. So to get my new j, first I put my y coordinate. I had negative 4 as my y, so that's my new x. I had 3 as my x, so that's my new y. My new k, flipping the x and the y, I now have a negative 1 for x and a 1 for y. For my new L, continuing the trend, I'm flipping the 2 points. In this case, they happen to be exactly the same, so there is no change. My new M, flipping the coordinate points, I have a negative 4 for my new x, and I have negative 2 for my new y. Now that I have my coordinate points, I'm going to go ahead and plot those on my graph. So I have my J at negative 4, positive 3. That's my new J. I have K at negative 1, positive 1. That's my new K. I have my new L at -1, -1, which happens to be the exact same place we were in before. And I have my new M at the point -4, -2. So that's my new M. And now I want to go ahead and plot those points. Well, connect the points. I've already plotted them. And I'm doing the best I can to avoid where I wrote my markings so that it's clear where the points are. But sometimes you get a little closely connected there and it's kind of hard to tell. But I have my new L and my L in the exact same place. My shape has flipped over the line y equals x. The line y equals x goes on a diagonal through the points 1, 1 and -1, -1. So if I were to draw that line, it would be right there. So I should see that my shape has flipped straight over that line. So my points are directly across that line. They are, you'll notice that L and my new L are on that line y equals x, and that is why that point stays where it's at. It's because it's on the line that we're flipping over, that we're reflecting on.